Okay, so we're recording. Okay, so now let's move on to 5 through 8, which is all going to be U sub. Actually, before we do that, let's do 10 because it's very similar to the problems we just did, just so we get more practice.
More U sub.
No, 10's not U sub. 10's just doing the antiderivative of each of those individually. So if we look at 10, okay, so let's do each of those individually. So start with 1. So we do antiderivative of 1.
Yeah, so that's just x.
Mm-hmm. Keep moving.
Wait, this is 10, right?
Number 10, yeah. Then so we're working on this part right here. So derivative 1 is x, and then you have x to the 5 halves.
So yeah, x minus x to the 7 to 7 halves.
Good.
7 halves over 7 halves.
Mm-hmm.
And then minus x to the 1 half over 1 half.
Very good. And then we just simply flip those fractions over.
Yeah.
Should be very seamless.
X minus 2 sin x squared minus 2x.
Now, your exam later this week.
Is it later this week?
I don't know. I'm just asking. I thought you said.
I don't think it is now.
No, okay, no worries. Okay. Well, would it be whenever you have an exam again? Would it be a free response or multiple choice? Do you have to upload your work? Like, how does your teacher do the tests?
Just basically upload our work after.
Okay.
After
so
exams.
Okay. So she makes you like do a test as a free response. Okay. 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 Now we're gonna do. Oh goodness. All right. Let's see. Delete. Okay. Now we're gonna work on 5, 6, 7, 8. Okay. So 5, you're gonna do U sub. And actually, let me erase this stuff here too. Okay. So I would let U equal 5x plus 7. Usually you let U equal the big expression that's in parentheses or under a radical, because then the integral becomes this, square root of U times dx, or U to the 1 half times dx. However, you got to do something about dx. And that's not hard, because you could just, when you have U equals 5x plus 7, du of dx is just 5. du is 5 dx. dx is du over 5. So U to the 1 half times du over 5. So now you integrate that. That's 1/5 times U to the 3 halves over 3 halves. Okay, plus C. You flip that over.
Let's see.
And then you bring the 5x plus 7 back in. So it's 2/15. And that's 5x plus 7. And you could probably leave it as 3 halves. I mean, I don't think that matters. To put it back as a radical, I don't think it's necessary. And we're A-OK.
Mm-hmm. Yeah.
Okay. Okay. So that's number 5. Okay, now I'm going to have you try number 6. Well, actually, let me help you with 6, and then I'll have you try 7, 8 on your own. I'll probably do it on a piece of paper, and we'll compare our answers. But let me help you with number 6. That was also a little strange. So I could probably just clear my screen now. All right, for number 6. Now, again, you usually let u equal whatever's underneath the
What's in the
parentheses
parentheses?
or radical. And also, you should let u equal the expression as a higher exponent, because x cubed is a higher exponent than x squared. So we let u equal 2x cubed plus 1. So d over dx is 6x squared. So du
6x.
so dx is d over 6x squared. So it's a very automated process, right? You know, just do a derivative, isolate dx. Now we're going to, this is kind of the part that's kind of like brain surgery a little bit. Like you just have to be very careful. 2x cubed plus 1 is u, so that's u to the 7th power. You have x squared, so leave that alone. But dx is d over 6x squared. And the thing is that the x squared should cancel. You have the 6 on the bottom. So it's 1/6, you can push off to the left, u to the 7th power times du. Now we integrate this. 1/6 times u to the 8th over 8 plus c. And we're use 2x cubed plus 1, so final answer will be 2x cubed plus 1 raised to the 8th power over 48 plus c.
C.
And again, if you want to do the derivative to kind of prove it and do the chain rule, you can. But I think at this point, we just have enough faith that we've done it so many times that we are integrating correctly. But if you were to do a derivative and do the chain rule, yes, you should get back to the original expression. So, so that's number 6. Okay, so I'm going to leave this up so you have a guide to follow. I'm going to have you try number 7. I'm going to just somewhat set it up for you just a little bit and want you to try it. And I'm going to get a piece of paper and I'm going to do it on paper and we'll see if we get the same answer. So this is going to be x times, I kind of separate like that, 7 minus 6x squared
Let me pull that up.
raised to the 1/3 power because it's a cube root
Let me pull that.
times dx. And you're going to let u,
Yeah, it's 7, right? So
yep, and you're going to let u equal 7 minus 6x squared. So you're going to go through the same motions, you know, find du dx, isolate dx, then replace stuff in the integral, work it out, and then bring back the 7 minus 6x squared at the end. So I'm just going to step away and grab a piece of paper and make sure we get the same thing. So hold on. And when you finally have an answer, let me know. We'll compare. Okay, how's it going?
Still doing it.
Okay, take your time. I also did number 8 too, so we'll do that next.
Negative 116, 7 minus 6, x squared 4/3 plus c.
Awesome, you nailed it. Good work. Fantastic. Love it. I think you kind of get the point. So I'm just going to kind of tell you how to do number 8, like just like what you would do, but I want to move on to trig.
How somewhat solves it if you can't see.
Oh, hold on. Let me take a look.
I don't know if you can.
Yeah, I can see. Hold on. Let me go to speaker view. Okay. If you hold steady, please. Thank you. Okay, you're fine. Good. Thank you. Good. Good work. All right. So number 8, just really quickly, what you're going to do is you're going to let u equal that expression. And then you're going to do du dx, which is going to be that, you know. And you're going to do a little switcheroo, right? Like du. And I would advise you factor out the 3.
Yeah.
Because then when you bring dx back in, you could cross it off with x squared minus 1 over here. And then we'll just make the work much easier. So that's just something to just keep in mind that, you know, sometimes you'd be crossing off, you know, bigger expressions rather than just crossing off x. So, so that's number 8. Again, I'm recording all this. I'll share the recording to you when I'm done. Okay, let's start with 11. So again, usually whatever has a higher exponent is what you're going to let u equal. So in this case, I would let u equal cosine x because it's raised to the 10th power, but just cosine x, not cosine x to the 10th power, just cosine x. And the root cosine we know is negative sine. So remember, we have formulas for that. I may have emailed that to you a while ago. And you want to isolate dx, so you just kind of multiply this by dx. Whatever is be multiplied dx, move to the side. Okay. Now we will integrate the sucker. That's going to be u to the 10th power times sine x times d over negative sine x. And if you can push the negative off to the side if you like.
Mhm.
Add 1 to the exponent, divide by a new exponent, plus c.
Yeah.
So it's negative 1/11th times cosine x raised to 11 power plus c. There we go. So not too bad. Let's do something that's kind of, well, give me a sec here. This one was a little more tricky. That was a pretty easy one. Let's see here. We'll just do them in order. I'm just trying to see. So we'll do 12 next. I'll do it in green.
Okay.
Okay, so it's cosecant squared 12x. Actually, let u equal 12x. The reason why I'm letting u equal 12x is because there's actually a formula for cosecant squared. And of course, that's 12. If you move things around, you get d over 12 equals dx. Yeah, this is where I'm going to consult my notes here. Here we go. Yeah, so you see the derivative cosecant squared. So the derivative cotangent is negative cosecant squared. So the antiderivative cosecant squared will be negative cotangent x. So this is actually a really good. I mean, actually, now I do recall. Do you still have that sheet saved somewhere?
Yeah.
Okay.
Yeah.
I could always resend it to when I send you the recording, because that's sending a link for the recording.
Okay.
Because I'm going to upload the recording to YouTube, and then give you a YouTube link. Anyway, so yeah, so now I know what dx is. So I'm integrating cosecant squared of u times du over 12. And the antiderivative of that's going to be negative cotangent u. Actually, it's 1/12, so I should put the 1/12 to the left, and it's negative. Plus c, or negative 1/12 cot 12x there you go. Okay. So that's number 12. So 11, 12 we're okay with? Those make sense?
Yeah.
Okay. Let's try 13, because that's also a little bit different. And then I think we're ready to have you maybe try a couple on your own. Now that's weird. That's sine cubed. If you have like a cosine connected to it, that's fine. But it's a little strange. So what you're gonna have to do, you're gonna have to do a little bit of you're gonna have to kind of tap into some of your pre-cal knowledge here. I'm gonna rewrite this as sine 5x times sine squared 5x times dx. Sine squared I know is 1 minus cosine squared. Okay. And then what you can do is that you could let u equal all this. because it has a higher exponent. So I'm going to need some space. I'm going to erase all this stuff here. Okay. So we let u equal 1 minus cosine squared so du dx will be 0. And that's going to require a chain rule. So we have the 2 to the front, cosine 5x. Oh boy, hold on a sec. I think I really messed this one up pretty hard. Give me 1 second. I didn't quite mess it up. I think I'm doing something wrong with. Okay. Let me backtrack a little bit. This is why I'm glad I'm doing the recording, so you have this as a guide for your test. You should definitely jot this down afterwards. But okay, I should distribute the sine 5x first. That's one thing I forgot to do. Plus, yeah, times dx, all that times dx. Okay, got it. Okay, I'm now going to break this up into 2 intervals. Sine 5x dx and sine 5x cosine squared 5x dx. Okay. Now you integrate. You could do that on its own. That's just negative cosine 5x and just divide by 5. So it's kind of like a reverse chain rule. You could just do that. And don't worry about plus c because we're going to do it at the end. Here, you're going to do a u sub. That's a mistake I made earlier. So you let u equal cosine squared. Actually, hold on. Am I doing that right? Hold on. Oh no, you let u equal cosine. Okay, I'm just losing my mind today. You let u equal cosine 5x because that's the highest exponent. So du dx is negative 5 times sine 5x. So you move dx to this side, you have du over negative 5 times sine 5x. Okay, so now it'll cancel out nicely. So now you got the integral.
Yeah.
And you get a u squared. Yeah, and then you have to integrate that. That's going to be double negatives make it a positive. And that's u to the 3 over 3 times negative 1/5 plus c. And that just kind of copies over. And then you bring the u back into the mix, which is cosine 5x, and you have your answer. So it's just, yeah, it's just a really kind of nasty kind of problem, but you have to kind of do that kind of creativity that with yeah, it's just kind of nuts. Let me do 14, then I'll have you try maybe
Okay.
15 and 16 on your own. Okay. Now 14 is interesting because I see tangent and I see secant squared. And if I look at, derivative of tangent is secant squared. So I'm inclined to let u equal tangent because derivative of tangent is secant squared. And plus tangent is raised to the 6th power anyway, right? So you can do integral of u to the 6. And we get pretty quick with this, right? U equals tan x, right? So d over dx is secant squared x. And then, yeah, it's d over secant squared x. And that's u to the 7 over 7 plus c. And then bring the, tangent back in. And voila, there we go.
Mhm.
Okay, so now I'll leave it up as a guide. Let's actually have you do 16 on your own. For 16, we're going to let u equal 1 plus cos x. So you'll need to find the derivative. I'll let you do that. And then you'll need to isolate dx. Then you do the substitution. Things should cancel out nicely. And then you, of course, integrate it with whatever u is. And then you substitute for u at the end. So I would do it now. And then we will, and I'll do it as well. And we'll see if we get the same thing.
Mhm. Do I know which one exactly?
So we're doing 16
Yeah.
in red. Okay, while I was at, I also did 15, which is kind of a doozy. How's 16 going?
-1/3 1 plus cosine x cubed plus c.
Fantastic. You're doing great. Good. You're getting it. Perfect. Good. Awesome. Okay, 16. Sorry, 15. Let me show what's going on with that one. So the thing is that secant's being raised to the 8th power, so that's obviously what we're going to want to let u equal, but it's important that we kind of look at the derivative of secant x, which is that, right? Secant x tan x. It's a little funky, so what I'm going to do is a little trick here is rewrite this before I do any integrals or integration or u sub. I'm going to say this is secant 7 of 3x, and then times secant 3x times tan 3x, and then times dx. Same thing, right? Just you break out the secant 8 as secant 7 times secant. Same thing.
Mhm.
And then I'm going to let u equal secant 3x and du dx equal the derivative of that, which is, of course, there's a chain rule, so you got the 3 to the front. And derivative of secant is secant tan, but your inside, of course, is 3x. And then we need to isolate dx, so dx goes off here. Three secant 3x tan 3x. And then we bring it back into the mix here. So you have the integral of, u to the 7th power now, because that's what you're letting u equal. U is set secant 3x, so it's u to the 7th power. Times, all that junk, secant 3x, tan 3x, and dx is that giant junk there. But, you want junk to cancel, right? That's the whole point of this. So you just gotta be awfully careful when you're substituting. So yeah, these cancel out very nicely. There's a 3 in the bottom. So now you're just integrating this 1/3 times u7 du, or you put the 1/3 off to the left, doesn't really matter. So it's 1/3 times u8 over 8 plus c, or it's u8 over 24.
Yeah.
And then of course u is secant 3x, so it's secant to the 8th power of 3x all over 24 plus c. Easy peasy.
Yeah.
Yeah. So that's what's going on with that one. Okay. So now let's take a look at 17. So 17, what I'm going to let you do is let u equal x squared. Find du dx. Isolate dx. And then you're going to do your substitution and then do your integration after that. So I'm going to have you work that out right now. So again, figure out du dx, isolate dx, substitute for dx, work it all out, and you should be able to get the answer after that. So I'll let you do it.
Yeah. 17, right?
Sorry, say again?
17,
17,
right?
yes, that's correct, yes.
Negative 1/2 cosine x squared plus c.
Hold on, so repeat that one more time.
Negative 1/2 cosine x squared plus c.
Cosine x squared plus c. Have a derivative. Okay. Good. Excellent. We're at the home stretch here. So for 18, because I see a cosecant squared, I mean, again, using my formula sheet, cosecant squared is right there. So I'm gonna, I know the answer is gonna be cotangent. So that should be pretty easy. And there's a 20, so whoop-de-doo, right? It's just negative 20 cotangent x plus c. I mean, it's just that simple. It's that easy. That's kind of giving me like number 9. Okay. Here, I'm going to let you, cosecant squared, that's not too bad. So you could do this. You could, the x times secant squared of x squared dx. So derivative of secant squared is tangent. Yeah, so we're gonna let u equal, before we get too carried away, let u equal x squared. Du dx will be 2x. So dx is du over 2x. So then you could say it's the integral of x times secant squared u times d over 2x. So it's 1/2. Just secant squared is tan. So it's 1/2 tan u plus c, and then you bring the x squared back in. So that's that one. And then lastly for 20, one sec here. I guess we could say, I guess you could say this. You can rewrite sine cubed x times cosine squared x times cosine x. Cosine squared is 1 minus sine squared x. If you distribute, then you get this. Sine to the 5th x, actually.
Yeah.
Yeah. And then then you kind of do each of those individually. They're kind of their own u subs, like let u equal sine x. Actually, you can just let it equal for the whole thing. Let u equal sine x. So then du dx is cos x. I say dx is d over cos x. So you're integrating, so I'm going to pull out cosine x off to the left here. You're integrating u cubed minus u to the 5th power, because now you kind of know what's going on, because that's u cubed to 5th. Put that in parentheses, that's d over cosine x, which cancels with that. The integrates u4 over 4 minus u6 over 6 plus c, and then you bring the sine x back in, and that's going to be your final answer. It's sine 4 x over 4 minus sine 6x over 6 plus c. And if you were to do the derivative of that and clean it up, I think it would work itself out. So anyway, that's that one. Okay. So yeah, mechanically, I think you've got this. It was easy to read your work. You have all these worked out. You have, I would probably, what I would do is, go through these again. Maybe look at my video. And you could like kind of fast forward through certain parts and just kind of make sure you have all these kind of like in front of you. And don't forget plus C. That's very important. Maybe put a little post-it note by your computer. Yeah, that's it. So.
All right. So I guess I'll see you on Thursday.
Thursday at 3 o'clock. That's correct.
All right.
Yeah. Okay, cool. Well, enjoy the rest of your weekend, and I'll talk to you later. Goodbye.